Okay, guys. So um, today let's discuss um the behavioral structure and the way it is designed. Then from there, we are going to write um, a code. Um, this time we are going to use C. I've missed using C. So today we are going to use C, not assembly and not C++, but we're just going to use C to write a program that's able to use analog digital converter with attached potentiometer, of course, to port A, and LCD to display values between 0 and 1023 or 1023. So that's what we are going to do today. So we can begin. So we'll begin by looking at this. So if you look at this PDIP diagram of an AVR microcontroller, you understand that at port A, the port A family is where you are only going to find internal built analog digital converters. So as you can see here, you have got all of port A has got analog digital converters from 0 to 7, like that. Then if you look at port B, we have got the clock there, external clock, you connect to port B0. Then you've got a timer one, which is also an external timer. Then an internal timer 2, analog in there. Then analog in one there. Then you've got MOSI. MOSI is basically just a master. Okay, it's a master slave. Okay, of usually when you're programming EEPROM. Then you've got system clock and all that stuff. So my point here is that the only port family which has got internal built analog digital converters is on port A. You know, you can look at this, for example. If you wanted to connect an external clock to AVR, then you come and connect it to port A0. It's not going to work because it cannot be recognized. But if you look at port B0, you will find that on port B0, you can be able to connect an external clock there. And an internal system clock is already present at port B7. All right. So if you want to use an internal clock, it's better you call port B7 like that. So this port A has got addresses that you program in order for you to use the analog digital converters there. Okay, so there are about 7 steps that you can follow if you want to program analog digital converters of an AVR microcontroller. In this case, we're talking about an ATmega32 or ATmega16 because these two are very similar. The first thing that you need to do is to make the analog digital converter channel pin as input. You declare it to be an input channel. Sometimes even if you didn't declare it, it will still work, but the best practice is to declare it, especially if you're handling higher voltages. Then the second thing that you need to do is to set or to enable the ADC bit, okay, which we basically call ADC SRA. Okay, then after you do that, when you do that, it's more like you're setting the prescaler or the divisor that you're going to use. It can, if you want to count maybe your display to display numbers between 200 and 0 to 255, your prescaler should be 8 because 2 to the power 8 is 255 or 256. Okay. Then the third thing that you need to do is to select the reference voltage. So if you're using the internal voltage, you're going to use AVCC. If you're using external voltage, you're going to use analog reference voltage, which is this one here. If you're using just 5 volts internal, like, you're going to use this one here, which is the AVCC, which is the analog 5 volts DC VCC. Then the fourth thing that you're going to do is to select the input channel. So you had set your input channel to be input, but which one exactly? Because there are 8 of them between 0 and 7. So how do you do that? You use the AddMax, or that's multiplexing register, by using an AddMax command in order for you to choose which one is going to be your channel, to be a usable channel in that particular program. Then the first thing that you're going to do is to actually start the conversion by setting the ADSC in the register ADCSR to equal to 1, so that it's enabled. Then you wait for the conversion by keep polling by using the ADIF bit in the ADCSRA register. Then after you do that, then you're going to use the ADCL or ADCH register to get digital output. So the ADCL keeps the lower nibble of the value, and the ADCH keeps the higher nibble or the upper nibble. Then after that, you'll be able to read from the ADCL before you read from the ADCH. Otherwise, the results will not be valid. So those are the steps that you are going to follow when you are doing your programming using ADC. So let's try and write some program together here. Okay, so let's locate where we can find the Arduino. Where is this Arduino thing? So that we write our program. Okay. It's not anywhere to be seen. Anyway, we are going to use Cross Studio anyway, because we can't see we can't locate the Arduino. We can use the Crossworks. So okay, so we'll start the new file there. Now in this case, you're going to use C. Okay, let's do this. Let's try and use Arduino to write that code. Use Arduino to write the C program. We're going to write that C program. It's taking like forever to start. Alright, so this program I'm going to write in C. You can also write it using using Atmel Studio. You know, these are just IDEs anyway. Okay, so anyway, let's just go with the Crossworks. It seems like the Arduino is misbehaving, so we go with the Crossworks. Okay, so Crossworks has opened there, and we come here and create a new script, and that script should be C or C++, but we are going to go with C++, the C. Okay, then we call it LCD interface in C. Okay, so you see, we begin there. So the first thing first, we are going to define our CPU clock frequency. So how do you do that? We simply say include then AVR. Before we could do that, I think okay, it's all right. You can say AVR IO dot, that's input output library, like that. Then the next thing that we do from there, this one is we are using C. We're using C. So the other thing that we do is to say that, then we say define. Okay, then we say define okay, the CPU, and in this case our CPU is taking 8 million or 8 megahertz if you want, so we're going to call it 8 million. Okay, 8 million UL, like that. So we have defined our system clock. So the next thing that we are going to do there is to define our delay header, or to include that. So we are going to say include alright, so this is C. Include, this can also be done in C++, and there's a very marginal difference between the two. Okay, so delay dot h, alright, then you say include we are going to say include another library. Okay, so stdlib.h. okay, so I'm going to include the stdlib.h. okay, then the last thing that we are going to include is to include the LCD, LCD library, and we define which kind of an LCD we are using. So we're just going to use the 16:2 because we're not displaying much. Okay, just that. Okay, so we have coded that library, and yeah, we're good to go to start writing our program now. So like I said, the first step is to declare your input and output. So our ADC channel will declare it as an input in this case. So we begin by the function ADC init. So how do you begin a function? It's similar, just like in C. We begin by saying void. Okay, begin by saying the popular void, and we say void, and then we call our function. Our function is ADC init. So ADC init, then we now begin. So we say begin, okay, and then in our begin we can say that DDRA, because we are working with port A, which has got the analog digital converter, and so we are going to declare it as our input like that. All right, and then the next thing that we do is to choose the prescaler like we discussed, the ADC SRA register, and we put our divisor there, or our prescaler, and in this case we want to display between 0 to 1023, so we're just going to use our prescaler instead of using 8 as our prescaler. We are using 128. Okay, so we're going to say 0 by 87. Remember, in that code I wrote in assembly, I used 0 by 83 as our ADCSR A, and our addmax was 0 by 63, which was on port A3, but in this case we are using this, and that one was counting just up to 255, but now in this case we want to count to 1023, and our addmax will connect it to port A0. So by connecting to port A0, it means that we are going to have addmax equal to 0 by 40. If there's anything that you're going to have difficulties in understanding in this tutorial, you can leave a comment down there specifically on what you are missing out, then I can be able to reply. But basically this code is going to make you understand, it's going to help you understand the ADC, or the analog digital conversion. All right, so there we even do what we close. So we have initialized our ADC, we have done the initialization. So what do we do next? What we do next is say init. Okay, so we say init, or int if you want, in that manner, and ADC read. So we want now to read the ADC read. So ADC read, then we say the character channel, so the data type there is character, and then the channel. Okay guys, this is very, very simple, straightforward. If you just pay attention, at the end of the day you're going to understand. So maybe I should explain something before I progress. By the fact that you have put 0 by 40, you have set your reference voltage to be AVCC, which is the 5 volts DC, and you've also set your ADC channel to 0, so it means you're connecting to port A0. Okay, so how these numbers come about, it's another video, but for now that's how it works, and I assume you know how those numbers come. So quickly finish the program faster, and we are going to say begin. So when you begin there, what you are going to have is int, okay, so Then now you say add max. Alright, let me just make this more nicer. So we say add max. So add max is the analog digital multiplexing. That's what that actually means. So add max is equal to add max. Then we say that the channel, okay, we say that the channel, you know that just like C++, C is equally case sensitive. So here we are setting the channel to read. So when does it read? Is if the channel is set and ready to start reading that. So we're going to say channel. So here we are putting up that, and this is a bitwise. All right. So you say that, and then okay. So what you're trying to do here is that you are basically trying to set input channel to read. This is what you're trying to do. The setting to read. You're setting your input channel to read. All right. That's exactly what we're trying to do there. So then you say ADCS or A. Okay. Then you say that it's equal to, and you do that. So you are enabling it to 1. Okay, so you are starting the conversion, because when you enable ADCS or a register, it means that you are starting the conversion now. So when you do that, that means you want to start the conversion now by enabling ADSC. Okay, so when you enable that, it means that the conversion has started, and then you call a while function. You say while the conversion is ongoing, okay, you check now the status flag while that is going on, while ADCSRA is high, by means of loading the value of the ADCC bitwise. You actually check, okay, the status, the flag, is it enabled or not enabled? So in other words, what you're just trying to do there is to monitor the conversion. That's exactly what you're trying to do there. You're monitoring the conversion. Okay, so so you're monitoring the end of the conversion interrupt. That's exactly what you're doing there. So we know every time when you talk about a flag, we're talking about interrupts. Is it set or reset and all that stuff. So after that, then you call a delay function by saying delay. So you say delay in microseconds, that function, for about 10. Okay, then you do so this is your lower nibble. And then it's an integer ADCL. Okay, So it's now you read the lower one first before you read the higher, as we agreed. So what you're doing there is to read the lower byte, okay? Then you do the same by reading the higher byte, okay? So the higher byte is ADCH, and you multiply it with actually 255, okay? So because 255 by 4 times, it's going to give you somewhere close to 1023 if my math is correct. In fact, let's just call it 256, like that. Okay, so that is more like the multiplicating factor. So the higher 2 bits multiplied with a word like the multiplication factor. So after you do that, then you now simply say the higher nibble is actually equal to the higher nibble, or the reading that you have, the analog read is equal to the analog in is equal to the analog in for the higher nibble plus the analog in for the lower. Okay, so then you say return. So what are you returning? Not a 0, but what you have read, your analog reading, that's what you're going to return. You fed it in analog and it gave out you the analog. So that's what you're returning. Now the A in is a digital value. So that is a digital value that you are returning. Okay, you're returning a digital value. So now after that is done, then you call now the main function, so int main, and you now define what is going to happen in there. So they are just going to say character is string, and you actually use your array, and to hold a larger value, a larger number as big as 1023, that's about 4 digits, you call at least a 5 array. Alright, so after that you say int value, okay, then you say adc. So you're just calling function that you have already defined. When you call them, they'll just be happening in there. So if you remember, we had already done the int, the init. So the init was done here. The init there. There's a capital I made a mistake. So the init was done there, and we discussed in another video already how to use how these functions works like. So I guess there's no problem here because functions will remain functions whether you are in C or in C++. Okay, so we now do the LCD string. LCD string then what is that LCD string that you want to appear? There is the ADC value. Okay, ADC value. Which you have already defined the value here, right? And we have already defined the ADC. So here, right? So we displayed this and this, the ADC value, by using the LCD string function.
So you have initialized your LCD and you have written a string on the first line of the LCD by this command. Then you continue by saying wow, it's true. By that, wow, it's true. So while it is true, you continue writing to the screen. Okay, you continue writing to the screen. So you say wow, it's true. Then you say LCD command 0 by C4. So when you say 0 by C4, it's more like you're putting it's a LCD 16 by 2 cursor position, right? So you say LCD command. So you say LCD command LCD command LCD command, then you say this 0 by C4. You know what that number is in hexadecimal? Okay. Then we terminate there. Then the next thing that you do is to say value. So you read by saying value is equal to ADC read. ADC read okay, if you do your reading there, then after you do that, it means that you're reading from the value which you initialized here. You are passing on the argument of what the ADC has read to that value so that it can be displayed here as ADC value, as you call that string. So the next thing that you do from there is to say float values comma string. So you say float, oh sorry, you can just do this there. Now say float. Okay, then you do that. So you're converting your integer to string because that's what you'd be representing on the screen, rather. So you say float, then you say, because value was in integer, then you say comma, then you say string, comma, then a number 10, like that. So your conversion is done just by that line of code. Then you now come and say LCD string, then LCD string, like that. Then you terminate that. Then you say okay, so there then LCD string, then you say LCD string, then you provide where your data from the red value be displayed on the screen, and you end. And then you say return return 0. And there your program ends. So guys, this program does exactly the same as the program that we did in assembly, the program I did in assembly. But the only difference that I have done is that we have multiplied that value with this so that we get 1023 by using this multiplication factor here to display between 0 and 1023. And also we have changed it from port A3 to port A0 by using this addmax value there. So guys, thank you, and if you have any clarification on anything that you need to understand better, you can leave a comment.